Hello and welcome to my channel. My name is Brienne Beebe. I am a high school geometry teacher and I teach with interactive notebooks, and today we are doing the Unit 8 flip through. So if you've been following along, we're on Unit 8, which is coordinate geometry. This is one of my favorite units to teach because it's graphing and students know graphing. They've been doing it for a long time, which is not quite the case with most geometry topics. Geometry in our state is supposed to start in 4th grade and it's supposed to build year after year, but what actually happens is it gets taught after state testing, and sometimes teachers in the elementary school will skip it entirely for whatever reason. So a lot of times I have to really work in the first half of the year especially to get students on board with geometric thinking. But once we get to volume and now this unit, which is graphing based, they do a lot better because it's not something that's completely new for them. So we start out by doing review. We go over slope, y-intercept, the slope formula, finding slope, describing slope, whether it's negative, positive, undefined, or zero. So this is all stuff that they should have gone over in 8th grade and Algebra 1. The next thing that we go over is converting equations of lines. This may be new for students, so they might not have seen this before. I feel like they should have seen it before, but just having to fix the equation of a line before you're able to do some of the work, we go over it, and usually this is where students struggle, so I give them lots of practice on that topic. Then we do a couple of examples of just writing equations of lines when you're given certain information. Now I stick to when they're given a point and the slope because that's what they'll usually see in geometry. But there's so many different combinations we could be doing with this. We just keep it simple. And then I do a review of graphing. Most of my students are going to be really familiar with just put the equation into the calculator and get the table, but I like to show them how to analyze the equation where, you know, you look for your y-intercept, you look for your slope, and then you're gonna start from your y-intercept and count out whatever your slope is, the rise over run, to graph a line. And I tell them if you practice it this way, it's a lot faster. Now what's kind of ironic or strange is we don't actually spend a lot of time just graphing lines in the unit, but it's good for them to know anyway. Then we jump into parallel and perpendicular lines. So the next day I give them a little discovery activity. I have them graph 3 lines. They identify which lines are parallel. They look for patterns in the equations to determine how they would know if lines are parallel. Then we do the same thing with deciding which lines are perpendicular and trying to figure out what is happening with the slope to compare the perpendicular line equations. Then I'll introduce them to the theorems and give them a couple of really quick examples where they are just deciding if the lines are parallel or perpendicular. And then I explain to them what neither looks like, and I'll show them using the graphing calculator on the smartboard. So it's an emulator is what it's called, emulator software. And I'll show them what parallel lines look like, what the perpendicular lines look like, and then I'll give them a couple examples of neither, like how they look. Students get kind of confused. They're like, wait, what is neither? And then I give them an activity. It's a sorting activity on Google Slides where it has 16 equations, and it's actually 16 sets of equations. They have to decide if the equations that they're given in each set are parallel, perpendicular, or neither. So I love that activity. I've been doing that one for a long time, and I will link it below because it's actually available in my TPT store, but it's one of my favorites. Then the next day we go over writing equations for parallel lines and then perpendicular lines. So we talk about finding the slope from a given line. Sometimes it needs to be converted, and if it's parallel, we keep the slope the same. And if it's going to be perpendicular, we need to rewrite the slope so that it's a negative reciprocal. And then we find the y-intercept and write out the equation of the lines. This is kind of a big topic where students typically need a lot more practice. However, my students this year were really focused during this lesson. They said they just felt it was really easy and it made sense immediately, and so they did really well with the lesson. And then the next day we did practice. I gave them a worksheet. Basically it is an activity that I have on TPT, but After giving them an online activity the previous day, I decided to make the practice for this just like the simple worksheet, and I had them turn it into me when they were finished. I would check it immediately. If they made mistakes, I would talk to them about it, give it back to them to fix, and then take it back after that. So this lesson, I give it 2 days because they really need practice with it, but my students did really well. The next day we go over perpendicular bisectors. So going from the slope of parallel and perpendicular lines to writing equations of parallel and perpendicular lines, I'm explaining to students that we're just adding in another step. So when we get to perpendicular bisectors, I tell them we're just adding in like a step and a half kind of. So we go over midpoint, the midpoint formula, and then finding the equation of a perpendicular bisector when they're given 2 points. So they have to find the midpoint, find the slope, and then get their equation. We also have a couple of examples where they are given a graph of a line segment. So from there, they're able to get the midpoint, and they could actually get the slope right from the graph, which is a lot easier than having to use slope formula. After that, we do dilation of a line. Now, this topic, some teachers like to teach with the similarity unit. I like to teach it with the graphing unit. There's really not much of a story there. I just prefer it this way. I like to be able to, because we're getting toward the end of the course, go back and review similarity at this point. So I give them notes that are on 2 pages, and the first page is if the point or the center of dilation is on the line, this is what we do. The line stays the same. And then on the second page, it's what happens when that center of dilation is not on the line. So we have a few examples there. These are just so heavily based on state exam questions. Then we have partitioning line segments, which is one of those topics where I did not learn this in school. Like, I had to teach this to myself to be able to teach it to students, because this was so new when I think it was Common Core came about. We had to start doing this. Actually, that's definitely what it was. So we talk about what a partition is, a directed line segment, because before now, line segments can go in either direction and it's fine. I give them the steps for it. I really like teaching the process of this, but there is a formula. And this year, my students that I had preferred the formula. So I think I'm going to update the notes and add the formula on here so it's there for them. Because I'm not sure that the steps really, like as they're written here, are the most helpful thing for them. I think they actually would prefer a formula. I like teaching the process though. This unit is full of formulas, and they're all formulas that in my state students would have to memorize for the exam because they're not given to them. So for this lesson, I go over how to find the partition on a graph and how to do it using the equation or a process. My students usually do really well with graphing it. It's pretty simple, or it could be. It depends on the line that you have. My state though has been really just cruel. They've been giving examples or just questions where it's not easy to find using just the graph. Like, you would have to actually use the formula. Then we do the distance formula. So for my state, it's not just using the distance formula, it's about using it to find perimeter or area. So we start with 2 examples where it is just finding the distance between 2 points. We go over simplifying radicals, and then on the inside of the booklet foldable, we do an example of finding perimeter of a regular polygon, and then we do an example where we're finding the area of a right triangle. So I teach my students that they could either use the formula, or if they wanted to, they could use Pythagorean theorem instead. I love giving my students that option, especially because it's another formula to memorize, and you know, they could fall back on Pythagorean theorem if necessary. After distance formula, we move on to proofs, but I break it up into doing proofs with just the distance formula first. So before we get into the lesson, I give this to my students as a warm-up. I ask them what makes parallelograms, rectangles, rhombuses, squares, isosceles, triangles, and right triangles different from their other shapes in their categories, so that they're kind of thinking about, you know, opposite sides have to be congruent or diagonals have to be congruent, etc. So it's good review for them. And then we go on to our distance formula proof notes. So I explain to them that you're using the distance formula anytime you're trying to prove that something's congruent. We do an example with an isosceles triangle. we do an example with a rectangle and then an example with a parallelogram. This is actually the lesson that we just did today. This is going to be our last lesson before spring break. So when we come back from spring break, and it just fell this way this year, sometimes I would have done things a little bit differently. But when we come back from spring break, we're going to do a mid-unit review. We're going to go over some of those topics again, like parallel and perpendicular line equations, perpendicular bisectors, the partitioning of a segment, dilating a line, just so that we have that review, because, you know, we have a week off for spring break, so they're going to forget stuff, or, you know, they're just going to need a refresher. Then the next day, we're going to go on to our final topic of the unit, which would be completing proofs using the slope formula. So we have a review of what things are parallel and perpendicular. That makes parallelograms, rectangles, rhombuses, squares, and right triangles distinguishable from their other shapes, because those are the shapes that students are usually asked about. So that's our warm-up again, and then we have our slope formula proofs notes. We prove that a triangle is a right triangle, that a quadrilateral is a parallelogram, and that a quadrilateral is a rhombus, but not a square. So that's the overview of everything. After that, I would do some different practice activities with them, like just practicing proofs. I have like a very basic worksheet that I made using state test questions, so students can practice that. That'll be the day following our slope proofs. We can kind of talk about then how you could combine strategies using distance and slope formula for a single proof, and then we're just kind of starting our unit review and then taking our unit test. So that is everything for this unit. If you have any questions, please don't hesitate to ask, and as always, thanks for watching.